With question 1A. Okay, so we have question 1A here. It says solve the following systems by graphing and verify the solutions. It's like, okay, we can do that. When you're graphing it, once again, you decide what what method you want to do. Whether you want to do slope y-intercept or x-y-intercept or table of values, once again, it is up to you. But you also have to remember, though, that make sure you're picking an option that you know how to do. Because, well, that's the point of graphing, right? The whole point of graphing is to understand you know exactly what you need to do. Okay. So that being said, if we were to graph the first one in black using our XY intercepts here, we can zoom in. We can say, oh, for this one here, the slope is 2 over 1, and the y-intercept is not 3, but negative 3. And then for your second equation here, your slope would be negative 1 over 1, and the y-intercept here would be 0, because there's no number there. Plotting this out, the first one is negative 3 on the y-intercept, so y-axis, oh, that's negative 2. Y-axis is negative 3, just like that. And then we can draw our point. So 2 over 1 is the slope, so we go rise is 2, so up 2, right 1, up 2, right 1, up 2, right 1. And so we have our line there. For our second one, we start at the y-intercept of 0, which would be the origin, and then negative 1, 1. So down 1, right 1, down 1, right 1, down 1, right 1. If we wanted to draw the lines here accordingly, we can draw our line doing this, like that, and color that in red. We can draw another line for the second one here, just like that. And we can color that in black. And we can clearly see the point of intersection here. So the point of intersection here is right here on that purple dot. Can someone tell me what the point of intersection is? 1, negative 1, making sure that you're writing it in brackets with the comma, right? So 1, negative 1, correct. So that is the point of intersection, right? And we are good there. So that was the answer to question 1A. You had to graph it using whatever method you want, but the answer that everyone should have gotten is 1, negative 1 as your point of intersection. Any questions? Any questions here? Looks like we're pretty good. All right, let's go to our 2 word problems, question 2 and question 3. Question 2 was the MAC yearbook committee needs to choose between 2 companies to print the school yearbooks. Blue Heron Yearbooks charges $8,000 for setup and $4 per copy, while Miles Ahead Yearbooks charges $8,400 per setup and $3 per copy. Write an equation to represent the cost for each company given X number of copies. So first, let's figure out, right? We know copies is X, which means our cost C is our Y variable, right? Our dependent variable. So we know that things should be written in Y because MX plus B. For Blue Heron Yearbooks, which is our first one, can someone tell me the slope and the y-intercept if it's given to us? What's the slope here? Four is correct, yes. 4. And the reason you know that, we see the word per, which means the number that is related to that is almost always the slope, the rate of change, right? Because this whole thing here is the rate of change. We're looking for that keyword. So 4 is the slope. What's our y-intercept if it is given to us? 8,000, bingo, right? It says our setup is 8,000, right? Which is our initial value. So this is definitely our B value. For the second one here, what's our slope? 3, and the y-intercept, 8,400. So we can write down our two equations. So BHY, we can say is C is equal to 4x plus 8,000, while for MAY, it would be C is equal to 3x plus 8,400. Then it says, which company should the yearbook committee choose? Determine the condition under which yearbook committee should choose each option. You were supposed to graph this. Okay? My suggestion to you would have been to, hey, you should probably use a table of values to determine the points that you need. The reason why we have to use a table of values here is because, well, the slope is a significantly smaller number than our initial value. You're not going to be plotting 8,000, then 8,004, 8,008. Like, that's not helpful to you, right? So we need to be able to figure out a good scale for our graph. So if we do X and C for number of copies and cost, we start off with 0. And when you sell yearbooks, you don't sell like one at a time. When we are supposed to calculate, let's go with 100. Let's go, I'm not going up by 1, 2, 3, 4. That's not going to help us. But let's go up by a significant margin, which is by 100. Let's just do that. So we have 100, 200, 300, 400, 500. We start off for BHY at 8,000. That's our initial value. So at 100 copies, 4 times 100 would be 400, plus 8,000 would be 8,400. And then it would continue on, 8,800, 9,200, 9,600, and $10,000. For MAY, we do the same table here, X and C. And with that, we do the same numbers. For X, and for C, we now start at 8,400, but it goes up by 3 per copy. So 100 would be 3 times 100, which is 300. So we have 8,700, 9,000, 9,300, 9,600, and 9,900. Okay. Once we have that going, we can now plot it. First thing you want to do when you graph, number of copies. You label your axis title. So number of copies and cost. So I'll put number of copies down here. For here, our y-axis, we would do cost. So I'm going to write it. I don't know if this works. No, that's not work. Cost. I'm going to write it with my really garbage sideways writing. That's not bad. Okay, so we have our cost in dollars, we have our number of copies, and our title, it would be Y versus X for our default title, right? Cost versus number of copies. If you wanted to do a full sentence title, you could say, oh, the cost to create yearbooks for each company, right? Maybe that would be a nice title as well. This is just showing you that a generic title works just fine, making sure that it's Y versus X. It's always the dependent versus the independent. The hardest thing about this now here was the scale. For us, we want to hit 500. We have a lot of space to work with, so I'm going to go every 3 squares is 100. And that should nicely put, right, our scale evenly spaced out at 3 squares each. The hard part was our y-axis, our cost. However, if you guys remember, if we're jumping lines, we do a zigzag or a Z, right? In the axis we're skipping numbers for. I'm going to start at 8,000. So what does that zigzag mean? It's a break, and we said that it means we skip out all the numbers from 0 to 8,000 because we don't care. There's no number from 0 to 8,000 that we have in our table of values that matters, so we have skipped all the way to 8,000. What this allows me to do is then write down my numbers. Maybe I go every two squares is 400. So 8,800, 9,200, 9,600, 10,000, 10,400. This is nice because it means every square is 200. I'm just not filling it in to make my thing a little bit more clear. But pretty much for me, you can see every square is 200. So 8,000, 8,200, 8,400, 600, 800, 9,000, 9,200, 400, 600, 800, 10,000, 10,200, 10,400, so on and so forth. So we've created this, and now I can graph my beautiful art. So for BHY, I'm going to do it in black. I start at 0, 8,000. Then I go to 100, 8,400, 200, 8,800, 300, 9,200, 400, 9,600, and 500, 10,000. There's our nice, beautiful line. We can finish it off by drawing a straight line through the points, which I will do so with exact precision because I am amazing at this math. And soon you will be too. Next, we have our MAY company. Starts at 0 and 8,400. Then at 100, it's 8,700. So it would be around halfway up here because this is 8,600. So halfway up would be right there. Then 9,000, which is on that corner. 9,300, which would be right here. 400, 9,600. And then 500, 9,900, just right here. I think you guys can already see the point of intersection, which is fantastic. And I think you'll already see the issue. If you wanted to go up by ones on the x's, you wouldn't even reach the point of intersection, right? So you have to think logically in terms of the question. When I'm solving for number of copies, when you sell yearbooks at a school, even our school, we at Newtonbrook, we have 900 to 1,000 students. I don't think you'd be measuring number of copies with single digits going up by ones, right? Logically, it would be better to go up by hundreds just because of the sheer number we're working with, especially when we talk about yearbooks and school and students, right? So doing so, we get our point of intersection. Now, the question did not ask for what my point of intersection is, but I will not complain if you say, oh, POI, and you write it down here, is 400, 9,600. You can even see it on the table of values here. They have the exact same value at the 400 equals X mark. But that wasn't the question. That's not what the question asked for. The question asked us, which company should the yearbook committee choose, and what the condition would be to pick that yearbook committee. Okay? Or to pick which company. So can someone type in chat for me? Anyone can type in chat. Which option should they choose? When? When and which option should they choose? Which company? Option A before $9,600 of cost. You remember, when you're talking about a condition, you don't use your dependent, you use your independent. So could you change that? Option A before, if you make... 400 copies. Exactly. So you want to be using your X variable as your condition, because once again, if it's dependent, then you don't want to use that. You want to use X as your baseline. So you are absolutely right. We're going to write that out here. So we're going to insert our text box here. Put that right there. And let's say, and we'll say the committee should choose BHY, right, for when making less than 400 copies, and they should choose MAY if they make more than 400 copies. There's your full answer. Okay, that's important right here, right? Understanding, yes, we know that the POI means that both companies are equal, right? Oh, there's one thing I forgot to do on the graph, which is to label it. Always label your graph. So this is BHY, and this is MAY. So can you clearly see BHY is cheaper when you have less than 400 copies, and MAY is more cheaper when you have more than 400 copies. So if I ask you at Newton Brook with 1,000 students, which one should we choose? MAY. Obviously, if we were to pick this company, it would definitely be MAY, right? They're the cheaper option if we have 1,000 students. So there we have it. Okay. We're going to move down into question 2. But before we do that, does anyone have any questions? All right, looks like there are no questions. We're going to move to question 3. All right, this is the Netflix one. You guys are lucky the scale is made for you. So you are trying to decide which movie provider to sign up for. Netflix charges $24 per month and offers unlimited movie viewing. Cinema Now charges a monthly flat fee of $12 and an additional $2 per movie. Okay. Which provider offers the best choice? Demonstrate your reasoning. Okay. So, why don't we make a table of values for this as well? If you want to create an equation, we can do that. We'll do that second. But first, let's start with the table of values, because this is what most people go for. X, let's create our let X. So let X be number of movies. And how do we know that? How do we know that? It's because this rate right here, movies is the second word. And that's always our X variable. So let X be the number of movies. Let Y be the cost in dollars. Okay? So we can then create our table. So let's use Netflix first. For Netflix, at 0 movies watched, how much do we pay?
Solving everything from yesterday.
Yeah. So how much do we pay for Netflix if we watch no movies? $24. Still have to pay $24 per month. Right? It's 24 here. Netflix is $24 per month up here, guys. If we watch one movie on Netflix, how much do we pay? Zero is incorrect. None is incorrect. 48 is incorrect. $24. Rowie and Sion got it. It says they offer unlimited movies. You don't pay for an extra. And just because you watch a movie doesn't mean you don't pay the $24. right? You always pay the 24. That's what it means by $24 per month. X does not mean months, guys. X is not months. What did we say X was? Movies. Number of movies is our X. So we don't care that we're watching more than 1 month. We're considering it within the month. How many movies are we watching? So if we do 2 movies, how much are we paying?
24.
24. In other words, doesn't matter how many movies we watch on Netflix.
So, if you watch infinite movies, it's always going to be 24.
Exactly. Just like how it is on actual Netflix, right? It's literally you pay 1 month, you can watch as much as you want, right? That's the whole point of that streaming website. Now, for Cinema Now, they do things a little bit differently.
I have no idea what that is.
So for Cinema Now, they charge a monthly flat fee of $12 and an additional $2 per movie. So if it's 0 movies watched, we pay $12. 1 movie, 14. 2 movies, 16, so on and so forth. Perfect. So 18, 20, so, and we can kind of keep going from there. Okay. Now, if we were to create an equation for this, what is the equation for Netflix? If we were to create an equation for this, 24x is incorrect. Good try, though. Incorrect. Not y equals 24x. You're close, though. Y equals 24 is correct. Because the y-intercept is 24. The initial value is 24. The $24 is your fixed costs per the month. There is no rate. There's no rate of change. The slope is 0, right? You're not paying for any movie, so your slope is 0. Your rate of change is 0. As for Cinema Now, can someone create the equation for Cinema Now? Ooh, Gerald, so close. So close. Mercel's got it. 2x plus 12. Remember, if you see the word per, this is your slope.
Right? So a movie, and then it's $2 per movie, and plus that $12 every month or something.
Yeah. So as a result, if we're looking at a 1 month time period, it's $12 plus $2 for any other movie that you watch. So you got your numbers, Gerald. You just got them in the wrong spot. So be careful, right? Once we have that down, we can now graph it. Y equals 24 is easy. It's a horizontal line, guys. Straight across. We don't even need to draw the points. We can just say, hey, it's a straight line across. Boom.
That's 0.
Right? So the slope is 0. I'll do it in blue because it's kind of hard to see on black. So there's our first one. That's Netflix. So we're going to write Netflix on it. This is Netflix. Okay. For our Cinema Now, it starts at 0.12, then 1.14, 2.16, 3.18, 4.20, and we didn't solve the rest, but we can draw our line to figure out the rest for us. Drawing our line through all the points like this, and doing that in red, boom, we get our line, and this is Cinema Now. Do we have a point of intersection? Absolutely.
Yes, there is. It's that thing.
What is the point of intersection's coordinates? Oh, Milan already typed it. 624. Let me rewrite that because that's ugly. Can I erase, please? Thank you. This thing hates me right now. Why is this hating me? There we go. Okay. So 624 is our coordinate. And then, so which provider offers the best choice? Just demonstrate your reasoning. What would our sentence be? If we were to create a sentence that explains which company we should choose at which time, what would our statement be? When should we choose Netflix and when should we choose Cinema Now?
Netflix below for below 6 movies.
All right. Netflix for below 6 movies?
No, it's Cinema Now.
Okay, so we should choose Cinema Now if we watch less than 6 movies in a month, right? Because we're specifically talking about 1 month.
Anything higher, it's Netflix.
Anything more than 6 movies, we should choose Netflix. Perfect. That's a great sentence. I like that. Perfect. We should choose Cinema Now if we watch less than 6 movies in a month. And anything more than 6 movies, we should choose Netflix. Perfect. That's exactly what we want. That's a full explanation for that word problem. Are there any questions about this? We're good? Perfect. I think you guys understood this point of intersection pretty well. Just make sure you're able to explain your thought process. The important part is, can you explain? Because if you cannot, then we have a little bit of an issue. So please explain your thought process so that we understand how to do it. Okay? So that I can understand uh, how you're thinking about this problem. All right. That is it for 3.5. Congratulations. You've reached the end of Unit 3, which means we are now to prepare for our 4th test, because Unit 1 technically had 2 tests, right? So this is our Unit 3 test, which is test number 4. Okay, so we're going to do that. And to prepare for our tests, we always do our review. So if you don't have this prepared, you can go print it. It is 6 pages long, and it's our analytical geometry review. So this is our review questions that we're going to be doing. So once you have this printed, type a G in the chat so that I know that you're good to go. See, I'm with the Korean keyboard. I got you. I do that sometimes too. Or like you start typing something in Google or like your web address and you type in a completely different language. If 6 pages is kind of too much for you to print, that's fine. Leave it for now. You can print it at another time, or you can just work on a separate piece of paper. Whatever works for you, right? You're not forced to print it, but yeah. So don't worry. As long as you're ready to go, just type G. If you can't print it, just say I'm ready to go. Right? So we're waiting on 1, 2, 3, 4, 5, 6, 7, 8. We're missing Sina. Are you good to go?
I have no idea.
This is our analytical geometry review that you see on my screen. You should have that ready to go right now because we're gonna go over it.
I'm not sure.
It's on Google Classroom, just like your other worksheets.
Okay.
Kuzli, how about you? Yeah, that's fine. I'm just saying it's if I'm asking if he's good to go, right? So Kuzli's good to go. Nice. You also have a typo there in another language, but that's okay. All right. So let's go over this here. So the first page you'll see on the analytical geometry review, this is the general overview of the skills we've learned today, or sorry, not today, over the past week and a half about analytical geometry. Ever since you came back from winter break, we pretty much worked on analytical geometry. So let's go over all the basic skills that you need to know. Number one, you should, by now, everyone here should know what an equation of a line is. Every single person here in this Zoom call should know what an equation of a line is.
mx plus b.
Exactly. Y equals mx plus b. And that was the slope y-intercept form. And then I taught you later in that week about standard form, right? Which was everything on one side, moving everything to one side, ax plus by plus c equals 0, where those capital letters written there are integers, right? And the second restriction was that the first number, the first coefficient on x, has to be positive. Okay? So that was the standard form. We've seen it here and there. You should know that that is also a linear equation. The slope is represented by m, and the y-intercept is represented by b. And of course, we have the two types, which is the direct and partial variations. Hopefully, you did not forget about that from Unit 2. Okay. The next thing was the horizontal and vertical lines. These were unique ones, right? You can even write, instead of y equals b, if that confuses you, you can just say y equals a number and x equals a number, right? Where a horizontal line, because the slope is 0, it's y equals a number because all the y values are the same. And for a vertical line, it's a similar idea. The slope is undefined because it's completely vertical. And so it's x equals a number because all the x values are the same. And you can see the slope y-intercept form, the standard form, the slope and y-intercept for all of these. And you'll notice for the y-intercept, it says none. For the vertical, because, well, there is none. Okay? So those were your skills for equation of a line. Would anyone like any clarification on this first skill set? All right. Number 2, graphing with x and y intercepts. So to find the x intercept, we set y equals 0 and we solve for x. Then we can plot that point x comma 0 on the graph, right? For the y-intercept, it's the opposite. We set it as x equals 0 because it's on the y-axis, and we solve for y when we plot that point. So whenever I ask you, hey, find the x-intercept, find the y-intercept, and I give you an equation, no one should be hesitating on how to solve that equation. If you ever get confused or you ever get stuck, I don't know how to graph it, you should always know how to find the x and y intercept if you're given an equation. Every single person here should know how to do that, right? That is a skill we've practiced, and this is the main thing that's going to get you out of a pickle every time, right? You need to know, can I solve for my x and y intercepts? Once you have that, you can graph the line. All you need are your two x and y intercepts, and you can connect the line with those two dots, and you've created your line, right? So it doesn't get any more complicated than that. Okay. Any questions on that one? Of course, there's questions to help you out with these concepts, but for now, anyone have any questions? Going once, going twice. All right. Number 3, the point of intersection. We just talked about this. This was the last lesson of this unit. We solved our linear systems, which is two linear equations together by graphing it. And the solution we called the point of intersection, where the two lines are meeting. So we graph both of the lines, we figure out where they're touching, and we say this is the point of intersection by writing down the coordinate, right? Bracket x comma y, close bracket, right? And you should be able to explain it in case you are given a word problem, right? to represent your or share your reasoning onto why which option is better. Usually with graphing linear systems, it's usually comparing two different things. That's the best type of question there is. So can you explain yourself by graphing, right? And with words. The fourth skill we learned this actually closer to the beginning of this unit, was parallel and perpendicular lines. Parallel lines have the same slope, same plain and simple. Perpendicular lines have negative reciprocal slopes. And the way we check whether something's perpendicular is multiplying the two slopes together. And if they multiply to make -1, they are perpendicular. Okay? So if I ask you, hey, this equation, y equals -2x, give me an equation that's perpendicular to that. Any equation that you want, right? Can you create that equation for me? Or if I just say, hey, can you give me an example of two parallel lines? Can you give me an example of two equations that are perpendicular? You should be able to create that for me because it only has one condition. Can you write the equation fulfilling that condition? That's important. Okay? So once again, parallel lines have the same slope. Perpendicular lines, negative reciprocals. To check that, we multiply them to get -1. Our last skill that we did, writing equations of lines using slope and a point or just 2 points. Remember the goal here, number 1, if you don't have slope, you should get the slope. No other option. If you don't have slope, find it. Number 2, if you don't have the y-intercept, you can now use your slope as well as a point on the line to solve for your y-intercept, your b value. Once you have then found your m, your slope, and your y-intercept, your b values, you can plug those into the equation and write it in y equals mx plus b form. Okay? You don't sub in the point again, you leave y and x, right? So those were the 3 major steps in solving for your equation of a line with what you were given. So these were all the skills that you were kind of taught this unit, and you already know that you are already using previous skills that we learned. You're using algebra, you're using fractions, you're using how to find slope, right? All that kind of stuff, you've done it before in Unit 2 and Unit 3, and you constantly have to review that skill as we go into Unit 1, Unit 2, and going into Unit 3. And Unit 4, which is measurement and geometry, you're still going to use some algebra. So I believe Mersel was really excited to do angles. So angles are coming up, Mersel. Angles are coming up. Okay? So that being said, there are 5 pages of questions, all with varying different types of situations. Now for number 6, I'm specifically going to number 6. It says write an equation for each of the following lines with the whole page empty, because you're going to need a lot of space for this. If you want to do it on a separate piece of paper, feel free. Get the practice. You're given A to J, which is a lot. This is a lot of different situations to create equations of lines. And if you can do every one of these perfectly, then you're good to go for the test. I can guarantee that for this section. You should be able to, so number 1, you should be able to graph each of the lines given an equation. 100% you should be able to graph it. Okay? For question 2, A, B, and C, calculate the slope of a line that passes through each point. So this is just calculating the slope. Very simple. Calculate the slope. And then the final thing is determine the equation of each line. Right? All of this kind of stuff, we've done it. It's all about graphing. It's all about slope. It's all about equations. Milana, am I going to take this up on Monday? Yes, absolutely. I will be taking this up on Monday. Yeah, we're going to be taking up everything before we do our test. We will be starting at 9 a.m. sharp, because this is a lot of questions to go through. I will be posting a Google Forms on Google Classroom saying, hey, which questions would you like me to take up? And then you can pick. Okay? Because I will not have time to take up every single question, but I can take up most of it. That's the thing. Right? So we got to be like efficient here with our time because I still want to give you like an hour and a half to 2 hours for your test. Right? So we got to be efficient. So, question number 5, it gives you a slope, and all it asks is, if this is your slope for your first line, can you give me a slope that for a second line that would make it parallel, a slope for a perpendicular line, a slope for something that's neither parallel or perpendicular, right? Okay. And then we talked about number 6. Number 7, solving a linear system graphically, which is what we just did. And it says to check your solution. So can you verify your answer? Okay. We will be starting Unit 4 on Tuesday. Number 8 is a word problem with equation of a line. And same with number 9. And this is talking about point of intersection kind of idea. And then same with number 10. Okay. So there's a lot here. There's a lot. I'm not saying you have to finish everything. That's not what I'm saying. Because you have 3 packages of extra review that you are to complete. However, I am saying that I will be taking up this one because I believe the other 2 worksheets that I gave you on Google Classroom have answers to them. Correct? Right? If I remember correctly, the ones I uploaded, the other ones I uploaded have answers. So I'm going to double check that they do right now. Yes, so that one has answers, and this one also does it have answers? Yeah, it has answers at the end. So there you go. No excuses not to do the other 2 as well for extra practice. Okay. So we have we have technically 25 minutes left in the class. So once again, this is how we normally do things here. I'm going to end the stream